Maya. The Maya is taking EMG readings. EMG readings are going into the Unity software where we have a virtual hand that is mimicking the hand that's going on there. Servo motor, 90 degrees, turns, twist these guys in. Design is on torsion springs so it springs back when it's done and then it comes in. So when it springs in and back, in and back. And we have the full Unity, we have everything working. But it's software that we didn't develop is acting up right now. So there it is.
Oh, there it is.
Okay, power supply as well.
So she moves her hand, let's go, let go. And then moves her hand. And then it grips. I designed the 3D printed design. Nick did most of the code. He did the virtual hand, and she's demonstrated. So basically, just like e-nable, if you guys have heard of e-nable, enabling the future. It's a community-based organization based off open source, open code for prosthetics for children. Real prosthetics that you buy are very expensive, and as an adult you can probably fork that out because you're not going to grow out of it, but as a child you're going to have every year or so you're going to grow out of whatever thousands of dollars of prosthetics you have. And basically what it does is they're 3D printed prosthetics that are designed through some kind of EMG that's on your wrist or on your arm that goes to multiple servo motors or one servo motor and becomes your hand if you do not have a hand. And then with our virtual hand,
the prosthetic hand was the first idea that popped out, and one idea that I had was to have that in sync with a virtual hand for the purposes of having a remote doctor, just in case you have an expert surgeon on another continent, in another country. This is a proof of concept for being able to look through a camera, look at a robotic hand, or look at a possibly much down the line an augmented reality hand, and then the robotic hand would go in, and that was purposes of my idea. As far as the prosthetic hand by itself, it's actually, as Jason and I are both military veterans, it's something that is personal to us with wooden warriors and people that come back without limbs. I know a friend of mine is waiting for an arm transplant at the moment. He's a quadruple amputee, and the transplant, he just started a GoFundMe it's like $100,000 due to medication he has to take every day so his body doesn't reject the new arm, and so on and so forth. So going into prosthetics is near and dear to our hearts. So.
Anything else? We tied it up with Unity, C# code. Nick, you want to talk about the code?
There's serial communication going on between Unity software and the Arduino. After the Unity software has received the gesture information from MakeCU, it then translates that into a language that the microcontroller can understand, reproduce the actions.
Did you 3D print the hand this weekend?
Yeah, I just...
the MakerBots?
No, I brought my printer.
Oh, cool.
It's sitting over there.
What kind is it?
That's a flash forge chilling right there. But yeah, I actually started the design probably about 12 hours ago.
Oh, wow.
So that's why it's not that pretty. It's I had to really rush it. Printing takes time, and time's not really what we had. I mean, I can knock out designs, but I always have to wait on printing. So I got the concept down, knuckling and, like I said, torsion springs. and torsion springs bring it back. The biggest thing with e-nable hands is they usually don't have some kind of good retraction back to their open state. There has to be something going on, and my new thing that I wanted to implement into these hands is torsion springs to kind of bring them back to where they need to go. Can you do your hand?
Yeah.
Did you base this on any of the stuff from openprosthetics.org, or?
No, this is a pure. I could show you where I opened up the thing. It's pure designed by me.
Maybe in the next version, maybe worth looking at some of this, because I know there's been a lot of really good experimentation there for exactly the reasons you're looking.
Servo power.
Some servo powered, some various things, but basically it's just a community of people building open prosthetics.
Yeah, so like e-nable, yeah, awesome. Yeah, I go to a lot of maker fairs, and I meet a lot of people that do that type of stuff. Yeah, so I want to get involved in my ultimate goal. I've been wanting to do it for months now. Is to actually have my own design as e-nable that I can have up there. So I'm gonna probably take this home and make this look like a real hand and not like Frankenstein. But yeah.
Also, how would you improve it?
Just make it better. My tolerances aren't on point, like as you can see. There's some here. These are too tight right now. And just make it better overall.
I guess my question is, would you be able to implement single fingers?
Yeah, dexterity. Dexterity would be my ultimate goal. The best way to do that is either I can have some kind of pulley system, ring and pulley system on one servo, but ultimately it'll most likely need to be 5 servos with dexterity.
It may be worth looking into, this is a personal interest of mine, but it may be worth looking into who has tried the Mayo on amputees as well, because a lot of what it can receive depends on the fact that you've still got a hand there to receive signals, and it may have some limited response without a hand there, which may solve some of your problems because you may not be able to give it enough information to do 5 fingers, but enough to do basic grip, things like that.
Yeah.
It's worth looking into see what they've done.
Definitely.
We actually started with EMG, 3 EMG, individual EMG sensors, and what we discovered is that we weren't able. We weren't able to gather enough information to work with 5 fingers.
Right.
And the Mayo actually did just as good a job as the 3. So I think in the future we'll get more EMG sensors so we can get the necessary information for to actually go about that.
Yeah. I wouldn't want to get. Oh, sorry.
I was going to say, if you could, I'd work with your buddy too, because if he's interested in working with you, working with somebody who's really going to use it, that's just such a great goal. It's going to give you better feedback than anybody else could.
Yeah, I was doing some research on terms of like the anatomy of the human hand and the human forearm, and there are, not to like really go into pseudoscience, but like acupressure points. There's different parts that if you can get the sensor perfect there, you will get that tendon to that pinky to that. It's each one is different. Like you can see them as they go, and if you can get that EKG in that perfect spot, you have that dexterity.
So you're talking about actual implantation into the muscle itself, because that's no longer.
No, it would just be some kind of sensor.
Because acupuncture actually
it goes into the tissue. Yeah, so yeah, it would just be sensors.
Which is fine because with the EMG, obviously, like you said, all those muscles are very finely tuned to each of the ligaments off the hand.
Yeah.
Right? So if you could sense from each of them individually and get a higher resolution, then yeah, you would have a better hand, right?
Oh, excellent.
But the problem there is obviously that you'd have to put electrodes into the tissue and then into the muscle. As opposed to having EMG, which by definition will not have the same resolution.
I think that the other question here is that do you really need the full dexterity on your hand? Because maybe like there are like few standard way of like grasping things that can like cover like 85% of
everything you do.
Everyday life movements and still allow you to reduce the number of actuators and therefore the cost and the complexity of the system.
Yeah, keep it under $100.
Experts in work, you don't need us. Seriously, if you're working with somebody who really is going to use it, we could do all the mansplaining in the world, but you've got somebody who can actually tell you that's going to work. So that's awesome.
And also consider feedback for the.
Of course.
Yeah. All right. We're running out of time here.
What did you learn when you want to move your hand? It doesn't take 30 seconds to respond, right?
Yeah.
What did you guys learn from the project? How much information did you bring to it, and then what did you learn from it?
In regards to Unity, I just started learning it for a 3D user interface class, but I learned how to interface it with Arduino, how to send information back and forth. I personally had never worked with any of this before, so.
I mean, I learned a lot about the EMG and how that works, basically. But yeah, you guys?
Yeah, I learned.
I have to learn how to use an oscilloscope. Yeah, with ECG data. It's really interesting.
I learned about how to use the Mayo. I brought it over last night because I wanted initially to do heart rate and maybe do something with seizures, but you can't do the heart rate in the Mayo. So it's like a matter of learning about like what apps the Mayo can do, like using the Mayo market, and then we used it to like go to the Arduino, and then also to Unity and how to get the data to Unity too.